Hey, what's up guys? Today we're gonna take 30 minutes to try to solve this problem right here, the longest consecutive sequence of numbers. And in this, we're giving an unsorted array of nums, and we have to return the length of the longest consecutive element sequence. You must write an algorithm that's O(n) time. So O(n) time would mean we can't sort because sorting would be n log n time for the regular types of sorts. Unless they want us to do I thought there was a type of sorting that is constant. I mean the linear time, but I do forget what it is. And then nums. Okay, so an example here is we get nums, right? And then we think 4, 2, 1, 3, 2. And those are always 1 plus or 1 minus to each other. And then the longest would be 1, 2, 3, 4, therefore its length is 4. So we're not looking for a subarray, kinda. Over here will be 9 because it go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. And then over here will be 3 because we don't count duplicates. Okay, I think the easiest thing that we can do is actually make a hash map. We make a hash map and then because if we make a hash map and then we check if the values is in the hash map, and we can check if the value is 1 greater or 1 less is in the hash map, or like if the key is 1 less or 1 greater in it, and then we can add that into our and then we can increment a counter because we don't need to really output the end array, we just need to output the amount. So let's try to do that instead. Okay, so we're gonna do std unordered for map. I have 2 ints, and then unordered map of map. Yeah, and now what we're gonna do is we're gonna iterate through every element and see if it's not in the map, then we'll append it. If it's in the map, and then we will check if it's +1 or plus minus, and then if it's not, then we'll add it to the map, and if it is, then we will, if it is, then we'll increment a counter, and then if it's a duplicate, we'll just pass or continue. Okay, and to do this, we can write it like this. First, we can initialize the counter. And then for const numbers or index in nums for const auto index for nums, and then we're gonna do what's this? That's the thing, it's so much harder to do because we don't have a while loop. We'll just do a while let's do a for loop, a regular for loop instead, because we need the incrementing of I to save the index. Oh no, we can just make a set because the precision doesn't matter too. An ordered set. You right, guys. For oh shoot, I wish I didn't do that. Const auto of indexes, index in nums. Okay, so for that we're gonna check if it's in there. For to check, we could do std find, or we can find in the set of the map. So we're gonna do scene or auto scene. Auto scene will equal std be map dot find index. I don't know what is replacement. I've never seen replacement in my life. see, auto scene map index. Ooh. If if scene, so then this means if it's in there, if it's in nums dot end. So if we've seen it, then we'll see if we can increment up or down. We check the values up and down. So then you check the values up and down. What to do? If scene. How do I get the element? Oh, actually, I'm still working on how to do stuff with the unordered sets. So then we'll quickly look up unordered sets, how they work real quick. Unordered sets. STL. X. But how do I check an element? Finding an element. Oh, we can just do auto find. Or if it's not in the element, is not in there, traversing, deleting. Oh, I guess we could. Oh, never mind. I don't know. I'm quite silly. If we're gonna do another one, below or under. So then auto below would be also map dot, or I guess set dot find. We can change this to set also. What the heck? Set. Alright, set dot find of index plus 1. I don't want to be a constant. I want to be int actually. Oh, it is an int. I don't know what I'm doing. Int. Because it can't be constant either, because if it's constant, then we can't do anything. Okay, we're gonna do auto and then above, and then auto above set dot find index find. Okay, and then we're gonna do if auto not if below above nums. Yeah, so now we're checking if the number above or below is in the set, and then if it's in the set, we'll increase the counter by 1. Then counter plus equals 1. I need to counter plus plus. Okay, nice. Okay, and now we're gonna do if is not seen. So then if it's not seen, if else. Wait, oh, if that is seen, we'll do that. But we're gonna make sure it's not a duplicate. So then else if this should be actually else if else if we've seen it already. Wait, sorry. I'm just gonna confuse a little. So here we have if it's in the set, we check. The thing is, we don't want to check twice or thrice. That's the only thing. I think there's another loop we can go and do here too to check just in case. Oh, but it's not a map anymore. We can change the value to something else, but now it's just a regular set. Oh, if it's in there. Oh, if it's in there, we just continue. What? Continue? Because the knowledge is if it's already in there, there's no point to check if it's there or not. If it's in there, we just continue, and then if it's not in there, we check. Oh, oh my God! I'm actually kind of sad about that one. I should have known else. Okay, and now we just need to add it to the set, and to do that we can do the insert function. I'm pretty sure. So then we can do set insert index afterwards. So if it's not in the set and it checks already, it'll insert and then it'll go again. Then if it's in this set, then we continue. If it's not in the set, then we do this. And then at the very end, we want to return counter. Okay, let's see if there's any typos we can see quickly about sets, nums, indexes, counters. Oh no, it's quite silly. And let's just try to hand it in. Oh, it's doomed. If not seen and seen. Oh no. Okay, it's just sign 11 error, valid and iterator expression. I swear it was like auto. it's because we're doing a different thing. Usually it'll be the same here, the set. So we're finding it in the set, and then we're finding it into the nums. Yeah, that's the problem right now. Oh wait, I don't know why it's nums. It's reset. Anyways. Oh, and then these. And I can't spell. Wrong answer. I got 2, and then this would be 4. So what's happening here? So we're saying that 4. Oh, that would make sense. Because it'll be 4. Because if 4 goes into here, it's gonna do, where am I? So then it's gonna loop, and gonna start at 100. 100 is gonna be, if it's in the set, it's not in the set. If it's one below, and if not, I counter it, and then we start 100, okay? And then afterwards it'll go to 4, and then we'll check if 4 is in here. And then we'll be like, oh, 4 is not in here. But 3 and 2, 4 is not here, because above 4 is 3 and 1. I mean, 3 and 5, so it's gonna say it's not in here. So I'm gonna insert it in there. Then 200 will come in, it will be nothing. So I kind of still at 0. Okay, so then 1 will come in, and then it'll be like, oh, because the thing will be 1 and 3. I mean, 0 and 2. 0, 2 would not be in here. We just increase it twice? Let's run this actually. Let's see what the test cases will say. If we're just below 2 each time, or half, then expected 5. We get the 1, then the 2, 3. Oops, I don't know how to delete this page. I think I'm understanding it now, because what it's doing is, because say a number is like number like 2, we're only, if it's just 1, because we're checking if it's above and below, but it's both below and above, so then we need to have another for loop for that. So we need to check, I mean, not a for loop, we just need another if statement. So if it's only above 1 or the other, then we can increment it once. But if it's twice, if it's both of them, then we have to increment it twice. Okay. Else if, there we go. And then we can go up here, go if below equals set dot and, does not equal set dot and above not equal set dot end. Okay, and then if it's both of them, then we're gonna do counter plus equals 2. Because if it's both of them, then it means both of them are up there. Oh, okay. Fingers crossed. That's so sad. Oh, whoa. Yeah. expected output is 8, but I got 9. I got 9, but it's supposed to be 8. Yeah. Shouldn't the 1 be both? Because 1 is not. Oh, 1 we tested already. I see the issue now. So the issue would be, so what we're doing is if 1 comes in first, this one doesn't matter if both 0 and 2 are in the set because it came first. So and then because we're continuing on the duplicates, so we've seen it again. We're just passing it instead. But now we actually have to choose which one to use, kinda. So that's probably the same with all the other test cases. So here, because 4 goes in first, 4 will go in and it'll find no one, and then 1 will go in, find no one. 3 will go in and find no one. 2 will go in and find 1 and 3, and that will give us 2. I think instead of getting a counter, I think we just append it and then we just put it into a list. Because if it's in there, like if there's a that won't do. This one is an odd one. Okay.
It's hard to get a 4 into the list without like saying why it's going into the list, you know? Like 4's gonna go into the list because to get 4 in the list. Any hints actually? Whoops. I guess they are using hash tables. I use hash tables. It's the way, but I don't know why. Because 4 would be the value of 2. 4 and 2. It's because we want to take the one with the further index in. Because if you think about it, if we take the index at the very end and we check it, then it'll have the most. So, I mean, no, that won't work in this case anyways, because the case over here would not do it either. Let's think. And sorry that random, return the length. Oh, and time. Then how do we check if it's in 3 or 4 in this array while being still in constant time? I mean, in linear time, that's the problem right now. Because if we just check the whole array itself, we're checking it multiple times, so we're pretty much n squared. And if we sort it first, if we sort the whole array, it'll be n log n. Unless it wants us to sort it by the tulips or something. Oh, I forgot what's the sorting called? It's where we take it, put it into a hash map, and from the hash map we can decompose the values into the base of a certain value, and then from that base we can insert it and sort it at the same time. And the thing is, we push, we pop. 4, 4, 3. And it's not, what's it called, question? It's not 2 pointers too, because even if we have 2 pointers, we find, okay, we have 4, and boom, boom, boom. Okay, we're gonna move that one. 100, we're gonna try, no, that's elite, stupid. I think this is the enemy. I know what's wrong with it. I don't know how to solve it. Maybe next time in life. I still have 4 minutes left, but it's better to cut it earlier than later. So, thank you everybody for watching. I'm watching this fail.